Now we will discuss how to represent real numbers on the number line through successive magnification. Suppose we have to represent the number, say 2.432. 2.432. Where does it exactly lie on the number line? On the number line, we have points like 0, 1, 2, 3, 4 and so on, and similarly we have some points on the left side of 0 as well. We can mark here. Now, exactly speaking, 2.432 lies between which two natural numbers? That lies between 2 and 3. So what we are going to do is, we are going to highlight these 2 points, 2 and 3. And now we are going to magnify. We are going to magnify the portion between 2 and 3. As we use a magnifying glass, so suppose we are keeping the magnifying glass on the portion between 2 and 3. And suppose we have magnified this area, the portion between 2 and 3. Now if I write 2 and 3 here, then I can mark 10 dots, 9 dots in between them. So they will represent 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8 and then 2.9. Now if I ask you, 2.432 lies between which two numbers on this second number line? More precisely, we can say it lies between 2.4 and 2.5, because it is 2.432, means more than 2.4 but less than 2.5. And now we will expand the portion between 2.4 and 2.5 on another number line. Like this, we can expand between 2.4 and again 2.5. So what we are doing here is 2.4 and 2.5 we are writing here. Now in between 2.4 and 2.5 there are so many numbers which lie. That is 1, it's 2.41, 2.42, 2.43, 2.44, 2.45, 2.46, 2.47, 2.48 and 2.49. Now if I ask you that 2.432 up to second place, if you see, it lies between which two numbers on this third number line? Now it lies between 2.43 and 2.44. That means these are the two numbers, 2.43 and 2.44. Again what we do is, we are going to take another number line and we are going to expand the portion between 2.43 and 2.44, like this. Suppose I write here 2.43 and here I write 2.44. Again if you mark the numbers, it will be 2.431. I'll take another pen. 2.432, then 2.433 and so on, 2.434 up to 2.439. Which was our number which we wanted to represent? That was 2.432, which we have already obtained here as 2.432. So this way, via successive magnification, we got into the depth of the portion between 2 and 3 and ultimately we finally reached the point 2.432. This is how we represent the real numbers on the number line by successive magnification. Now let us take one more example of representation of 3.765 on the number line through successive magnification. Now broadly speaking, 3.765 Exactly. Where does it lie on the number line? It lies between 3 and 4. So we have highlighted the numbers 3 and 4 on the number line, and now through the we are going to use the magnification, like we are going to use the magnifying glass, and we are going to magnify the portion between 3 and 4. So what we have done is, on another number line we have taken two numbers 3 and 4 only, and because we are going to magnify the portion between 3 and 4 only, and the rest of the number line we are not going to be bothered about. Now in between 3 and 4 there lies numbers like 3.1, 3.2, 3.3 up to 3.9. Now if I ask you that 3.765 lies between which two numbers on the second number line, surely you will say it will lie between 3.7 and 3.8. So now we are going to highlight these two numbers 3.7 and 3.8, and we are going to magnify 3.7 and 3. The portion between 3.7 and 3.8 on another number line. We will write 3.7 and 3.8, and now we will focus on the portion between 3.7 and 3.8. So what type of numbers lie between 3.7 and 3.8? Exactly, 3.7 can be written as 3.70 and 3.8 can be written as 3.80. So between 3.70 and 3.80 we have numbers like 3.71, 3.72 up to 3.79. Again the same question arises that 3.765 now lies between which two numbers on the third number line? Obviously it lies between 3.76 and 3.77. So we have highlighted these two numbers on the number line, and again we have expanded the portion between 3.76 and 3.77. Again, as you can see, 3.76 can be written as 3.760, 3.77 can be written as 3.770. So in between these two numbers, the numbers of the type 3.761, 3.762, 3.763 and so on up to 3.769 will be there. Now what is our number? Our number was 3.765, which we can easily locate on the number line, that is 3.765. So we know precisely where this number lies on the number line, and we could do it through successive magnification. Now let us represent numbers of the form under root 4.3 on the number line, or in other words I can say we are going to represent numbers of the form root x, where what is x? X is any positive rational number. Positive rational number. Earlier we had done those type of root numbers on the number line where x was a positive integer. Now they are positive rational numbers. Now let us see what are the important steps in representing under root 4.3 on the number line. First of all, when you have to represent under root 4.3 on the number line, we will construct a line segment of length 5.3. So as I have drawn a line segment AB, the length of this line segment is 5.3. Suppose if I have to represent under root 5.6 on the number line, then I will draw a line segment of length 6.6 on the number line. So I have chosen AB of length 5.3. Now from the point B, I will mark a point C, which is at a distance of 1 unit from B. So that means total AB was 5.3, whereas BC is BC is 1. So what is the length of AC? That is 4.3. And now we will draw the perpendicular bisector of the line segment AB. Children, I hope all of you know how to draw the perpendicular bisector of a line segment. Keeping the compass at the point A, take more than half of AB, draw one arc on the upper side, one arc on the lower side. Then with the same measurement, keep the compass at the point B, draw one arc on the upper side, one on the lower side, and join those 2 points. That gives you the perpendicular bisector. Now I have to draw a semicircle by taking D as the center. We will be drawing a semicircle from A to B. So a semicircle is created here, and now at the point C we will draw a perpendicular line. Okay, and now we join this point D with the point E. Alright, now this is what we have obtained. Now this is a perpendicular, so it's a 90-degree angle formed. Okay, now let us see which length actually represents under root 4.3 on the number line. Okay, now as you know, the total length AB that we had drawn in the beginning was 5.3 units, out of which AC was 4.3 units and CB was 1 unit. Now if you look at this semicircle was drawn by taking D as the center and AD or DE or DB as the radius. All three of them are the radii of the semicircle. So it means, what is AD equal to? AD will definitely be equal to half of AB. That means half of 5.3, which is equal to 5.3 upon 2, that is 2.65. Similarly, DB will also be equal to 2.65, this being the radii of the semicircle. And what is DC equal to? DC will be equal to DB minus CB, which is 2.65 minus 1, that is equal to 1.65. Also, DE being the radii of the semicircle will be 2.65. Now, in right triangle DCE by Pythagoras theorem, what do we get? That DE square is equal to DC square plus EC square. Now DE square, we know the length of DE, so let's substitute the value. What is DE equal to? That is 2.65 is equal to DC, which is 1.65 whole square plus EC whole square. Now 2.65 whole square minus 1.65 whole square is equal to EC square. So that will give you 2.65 plus 1.65 into 2.65 minus 1.65. We have used the identity A square minus B square. So what is A plus B? 2.65 plus 1.65 will give me 4.3, and 2.65 minus 1.65 will be 1, is equal to EC square. That means EC will be equal to under root 4.3. Our DE was 2.65. This length was 1.65, and by using Pythagoras theorem we got EC to be equal to under root 4.3. Exactly the same way as we did before. Now as we know, CE is under root 4.3. So by taking C as the center and CE as the radius, suppose if I draw an arc using a compass which will intersect the number line at some point, say F. So from C we have drawn an arc EF. So CE and CF are of equal lengths. So we have just now found CE to be under root 4.3. So CF will also represent under root 4.3. That means the length CF will be root 4.3. 3. So if I consider C as the origin, means point O, then point F will represent under root 4.3 on the number line, or otherwise you can say CF is equal to under root 4.3 on the number line.